So we're going to talk about functions here, okay? So we're going to do a couple examples. We're going to see how to find if a function is even and odd. And I think one question asked, is a function going to be even, odd, or neither? Well, a function can be both odd and even. There's one case, and to show you what that case is, well, first I'm going to talk about the definition of what an even or odd function is. So the definition of an even function is just that the function f, evaluated at negative x, is equal to f of x. That's an even function. And the definition of an odd function is f of negative x equals negative f of x. That's an odd function. An example of an even function would be, say, x squared plus x. An example of an odd function would be x cubed plus x, right? Notice that the constant 1 is an even power of x. X to the 0 is 1, right? So 1, 2, 3, 4, 5, all of those would be even functions. And x squared has an even power of x also. Now x cubed is an odd power of x, and x is just x to the first, and 1 is an odd number. Okay, so those are another example of an even function would say x squared plus x to the 4th. Say x cubed plus x to the 5th would be another example. Okay, so before we continue, you might want to ask, and we'll see why these functions are odd and even in a second. But someone had asked, is there a function that's both odd and even? Or a function could be neither too. But yeah, there is a function. Let's see what happens for a function to be odd and even. So if a function is even, we have f of x equals f of negative x. That's even. And if it's odd, that means we can pull the negative sign out. It becomes negative f of x. So if a function is both odd and even, we have to have that f of x is equal to negative f of x for any value of x. Well, that means, well, if we divided both sides by f of x, well, one possibility that f of x is 0, because 0 is equal to negative 0. So one possibility is the function that's constantly equal to 0. If it's not 0, we can divide both sides by f of x, and we get 1 equals negative 1, which is a contradiction. So there's actually only one function that is both odd and even, and that's f of x equals 0. Okay? Alright, so now let's see how we can tell if something's odd or even. So let's look at the function f of x is equal to x squared plus 1. Well, f of negative x would be equal to negative x squared, oops, we did plus 1 there, plus 1, right, because this is x squared plus 1, so f of negative x, I replace the x by negative x. Well, negative x squared is just x squared. Whenever there's an even power, parentheses raised to even power like that, that negative sign with the x is going to go away. So it becomes x squared plus 1, but that's exactly what f of x is equal to, right? F of x is just x squared plus 1. That's what we have here. So we have that f of negative x is equal to f of x. Sounds good, right? I think so. But what about an odd function? Well, one of the examples we have for the odd function was, so that means it's even. Alright, so the odd function we had was f of x, that was one of them, is equal to x cubed plus x, right? Well, let's see, well, we have f of negative x is equal to negative x cubed plus negative x. All I did was replace all the x's by negative x's up here. Well, whenever we have an odd power like this, when we have an odd power as a 3 or a 5 or something, we can take the negative sign right out. So this is going to be negative x cubed And plus a minus x is the same thing as minus x. Now what we can do is factor the negative sign out, and it's going to be minus x cubed plus x. But x cubed plus x is exactly f of x. So this is going to be minus f of x. But that's exactly what it means to be an odd function if we were to go to the other page. Negative f of x, f of negative x equals negative f of x, right? Negative f of x equals negative f of negative x equals negative x. So that's an odd function. How about a function that's neither odd nor even? Well, suppose we had, now the trick I gave you about the powers, adding even powers or adding odd powers, that only works for polynomials. So you should know how to check this. Because if you had something that wasn't a polynomial, then you would have to do what I'm doing here. But if you had a polynomial, you could just look at the powers of x and say, well, the powers of x even and the powers of x odd, and you're good. But let's take the case where we have, say, f of x equals x cubed plus 1. Right? Well, f of negative x is equal to negative x cubed plus 1 is equal to negative x cubed plus 1. Well, negative x cubed plus 1 is not equal to f of x, and we know that negative f of x would be equal to negative x cubed minus 1. Well, this is not equal to negative f of x either, so we know that it's not odd, and we know it's not even either. You can check numbers to see that it's not odd or even, because when you're going to show it something's not the case, you just have to find examples, and you notice that, say, f of 2 is going to be 8, and f of is going to be 9, I'm sorry, and f of negative 2 is going to be negative 7. And so we know that it's not odd, and it's not going to be even. I'll show you real quick. So f of negative 2 is equal to negative 2 cubed plus 1 is equal to negative 8 plus 1 is equal to negative 7. And we know that f of 2 is equal to 8 plus 1 is equal to 9. So it's not even, and it's not odd either, because negative f of 2 would equal negative 9, not negative 7. So it's right away we're checking numbers and know it's not odd or even. Okay? So graphically, okay, so what do these functions look like graphically? Well, an even function, like x squared, right, would be symmetric with respect to the x-axis, like we have over here. So see if you're on one side of the, the y-axis. One side of the y-axis looks like a mirror image of the other side of the y-axis. Okay, so there's that symmetry. That's what it means to be an even function. For instance, if we go out 3 spaces over here and up, it would be the same as if we went 3 spaces to the left and up. So that's what it means to be an even function. Now, with an odd function, so this is an example of an even. Now, an odd function, we have, say, something like this. So there's a symmetry with respect to the origin. Okay? So if we go, the idea of an odd function is if we go, say, 3 spaces to the right and evaluate f there, it's the same as if we go 3 spaces to the left and evaluate f there. Then the only difference between this side and this side is a multiplication by negative 1. Okay, so this kind of has a symmetry about the origin. So it just there's a mirror image flip as you go across the origin, so you can kind of see that, right? So the only difference of going 3 to the right and evaluating is defined, or 3 to the left and evaluating is a multiplication by negative 1. So if we multiplied this side of the function by negative 1, we would wind up with this point exactly over here. So, right? Okay, so that's kind of what that is, and I hope that explains it. And if you have any questions, please don't hesitate to ask. Thanks, and have a great day.